Hi guys, welcome to the Building Big Data Pipelines with R, Sparklyr and Tableau course. In this course, we will be creating a big data analytics solution using big data technologies for R. In our use case, we will be working with raw earthquake data. We will be applying big data processing techniques to extract, transform, and load the data into usable data sets. Once we have processed and cleaned the data, we will use it as a data source for building predictive analytics and visualizations. The tools we will be using are the following: Tableau Desktop, which is a powerful data visualization tool used for building big data analysis and visualization. It allows for data blending, real-time analysis, and collaboration of data. So no programming language is needed for Tableau Desktop, which makes it very easy and powerful to use, as well as allowing us to easily create dashboard applications and reports. And the next library that we will be using is Sparklyr. So Sparklyr is an open source library that is used for processing big data in R by providing an interface between R and Apache Spark. It allows you to take advantage of Spark's ability to process and analyze large data sets in a distributed and interactive manner. It also provides interfaces to Spark's distributed machine learning algorithms and much more. We will also be utilizing one of those machine learning algorithms in our big data pipeline. So what you'll be learning is you will learn how to create big data processing pipelines using R. You will learn machine learning with geospatial data using the Sparklyr library. You will learn data analysis with R and Tableau, as well as Sparklyr. You will learn how to manipulate, clean, and transform data using Spark data frames. You will learn how to create geo maps. You will also learn how to create dashboards in Tableau Desktop. Okay, so what we have in front of us is the final dashboard that we will be building in Tableau. So we will be combining multiple charts that we will create individually. And then at the end, we will combine each and every one of these charts, as you can see, into a full-blown dashboard. Okay, so the first visualization that we will create is the earthquake prediction map. So what this does is, first in our Sparklyr data pipeline, we will be cleaning and transforming data and then using that data in a machine learning algorithm, and we will predict earthquakes for 1 year in advance. And we will take those predictions and plot them on a map, which will be our earthquake prediction map. So these are the results that are derived from the predictive model, right? So these are the magnitudes of the earthquake that are predicted for the year 2017. So our data set will range from earthquakes for the year 1965 up until 2016. And then we will use machine learning to predict the earthquakes for the year 2017. And that is what you're seeing in front of you. Okay, so Tableau allows us to make use of very basic mapping tools, right? So we are using a inbuilt mapping tool which allows us to create map layers as well as choose different base maps. So I decided to choose the dark one that will allow our data to stand out. So each point is an earthquake on the map, and you will see that Each point differs in the color. So the darker shade, as you can see on the legend, tells us that it is displaying the magnitude of the earthquake, right? And if we see a darker green point, it tells us that it has a greater earthquake magnitude of up to 6. And if you see a yellowish color or light green, it means that we have a lower earthquake magnitude value of up to 5.7. Okay, so we have a color palette that we are using, and each point represents the magnitude of that specific earthquake, and then the color will distinguish between um, a low intensity earthquake and a high intensity earthquake in the range 5.7 up until 6. Okay, and then if we hover over a darker green point, we can see the geo coordinates of the earthquake as well as the predicted magnitude value, which is magnitude 6. And then if we hover over a yellow point, we can see a magnitude value that is less, which is 5.8. So the darker the shade of green, the greater the magnitude of the earthquake, and then the lighter the shade of green towards yellow, the lower the intensity of the earthquake. So if we zoom out, we can see where we have higher intensity earthquakes versus lower intensity earthquakes. Okay, so the simple mapping tool that Tableau provides us has a basic search as well that is built in. So if we want to view earthquakes in the Fiji region, for instance, we will just search for Fiji and it will take us there. And we can select a couple of earthquakes using a square. And if we right click on the point, we can view the data in a table. Right, so if we want to analyze the data, we can export it into a CSV file and then visualize it somewhere else. We can also view the full data set from where the data is coming for the points that we have selected. So we have basic near real-time data analysis that is available for us to use as well. Okay, and at the bottom, we have the maximum and the average earthquake magnitude value for each year. Okay, so starting from 1965, we have plotted on an area chart the maximum earthquake magnitude value for each year. And below that, we have the average earthquake magnitude value for each year. Okay, and then the next chart that we will create is the bar chart. So the bar chart will tell us the number of earthquakes for every year. So if we hover over it, we can see a number of earthquakes count value as well as the year. So we can see in the year 2011, we have the most earthquakes according to our data set. Okay, so the next tool that we will use to visualize our data is the donut chart. So the donut chart doesn't really exist in Tableau. We will be building a custom one using the pie chart. So this tells us the types of earthquakes that are present in our data set. So we have basically mostly earthquakes, but some of the data is explosions, nuclear explosions, and rock bursts. And we can see by hovering over the donut chart that the majority of our data, 99% of our data set, contains standard earthquakes, and just a minority contains an explosion and a nuclear explosion, etc. Okay, and we will be creating this dashboard solution as our analysis at the end of the course, right? And you're welcome to extend it to how you see fit. And we can also view the dashboard in presentation mode if you want to see how it will look after we have, or after you have exported the dashboard from Tableau, right? And this dashboard will scale to fit any screen that you want. Okay, and we can exit presentation mode. So basically we will cover a couple of topics ranging from importing the raw data, transforming the data, cleaning the data, transforming the data into a form that we can feed into a machine learning algorithm, and then training the algorithm, exporting the predictions, and then creating the visualizations. So I hope you guys will enjoy it and learn as much as possible. It is a very informative course, and it covers basically the entire stack in a data pipeline. So thanks a lot for tuning in. I'll see you guys in the course. Thank you.